to look at polynomial division. The first type of division we're going to look at is dividing by a monomial. And before I get into that, just kind of want to talk about like adding fractions to kind of, and you'll see the connection in a second. So let's say I have 2/3 plus 1/5, and I want to add those fractions together. Well, in order to add them, I need a common denominator. So I need to find a common denominator. In this case, the common denominator is 15. And to change this to equivalent fractions, what I ask myself is, what do you multiply the denominator by to make it this new common denominator? Well, I'd have to multiply 3 by 5. So I need to multiply the top by 5. And to multiply 5 and make it a 15, I need to multiply that by 3. So I need to multiply the top of that one by 3. So I get 10 15ths plus 3 15ths. It's the same as 2/3 plus 1/5. And then I add the tops together, the numerators, and I keep that common denominator as that shared denominator, and then 10 plus 3 is 13 15ths. Okay, so what we're going to do is we're going to look at a problem like, say, 3x to the 4th y squared minus 28x cubed y squared plus 24 x y squared. And we're going to divide that all by 4 x squared y squared. Okay? So what we're looking at right here is really like this 10 plus 3 over 15, and we're actually going to go this way with it. We're going to split it up into separate fractions with same denominators. And then we're going to actually reduce those fractions individually. So what we're going to do is we're going to split this up. We're going to say 3x to the 4th y squared over this common denominator, 4x squared y squared, minus 28x cubed y squared over that shared denominator, plus 24xy squared over 4x squared y squared. Okay, so sometimes people think, like they see this initial problem and they think, oh, I can see some stuff that I can cross off. You got to split it up into separate fractions, then do your reducing. So now I look at each one of these individual fractions and I start saying, oh yeah, like y squared, that cancels out. 2 of these x's cancel out 2 of these, leaving me an x squared there. And then the 3 and the 4, they don't cancel out. So I get 3/4, and you could write x squared on top, but usually if you just have a variable on top, you're going to write it to the side like here. So 3/4 x squared minus. And then I come to the second one. So y squared and y squared, those cancel out. This y squared cancel out 2 of these, leaving me an x. And then 4 goes into 4 once, and 4 goes into 28 7 times. So I have 7x over 1, which is really just 7x. Plus, I come to this one. And again, y squared and y squared cancels out. This x on the top cancels out one of these x's on the bottom. So notice this x is on the bottom. That's going to be important. 4 goes into 4 once. 4 goes into 24 6 times. So I get a 6 on top and a 1x, which is just an x, on bottom. And notice I still have a variable on the bottom. That's because I had, look at the original ones in this third term, and more x's on the bottom than I do on top. So you can get a fraction at the bottom, or at the end, with variables still on the bottom. So let's do another one of those just real quick. So let's say we have 24 x cubed y squared plus 36 x squared y minus 6 xy. I divide that all by 6xy. And again, somebody might say, oh, 6xy, that matches up my question. No, not yet. Not yet. Slow down. What we need to do is split this up into separate fractions. All over that common denominator, 6xy. And, you know, make sure you got everybody copied 3, 2, 2, 1, 1, 1. Okay. And then you can start crossing some things out. You can say, okay, this and this, cross off one of those, make that a 2. And then 6 goes in there once, 6 goes in there 4 times. So this first term is 4x squared y over 1, which is 4x squared, plus y cancels y. This cancels one of the x's, leaving you an x. 6 goes into 6 once, 6 goes into 36 6 times, so you get a 6x over 1. So 6x minus cancel, 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 cancel. So that is 1. 6 divided by 6 is 1. X divided by x is 1. Every time we say these cancels, each one of these becomes a 1. That becomes a 1 times, you know, 1, 1, you know. So these are all becoming 1s. I just don't bother usually to write the 1, but you can't get 0 unless you started with 0 when you're dividing. All right, let's look at the second type of division we're going to look at is long division. So again, I want to kind of do an example here to kind of see what's going on. We're going to write 237 fifths, this improper fraction, as a mixed number. Okay, so the way we're going to do that is we're going to say, we're going to do some long division here. We're going to say, let's have 5 go into 237. Well, 5 doesn't go into 2, but 5 goes into 23 4 times. So basically, I'm trying to match 5 to 23 as much as I can. And so 4 times 5 is 20. Then I'm going to take off the part that matches. And I have the part that doesn't. And then I'm going to bring the part down the next part of the expression. And I'm going to, again, say 5 goes into 37 now. 7 times. That's 35. That's as close as I can get to matching it. And then I'm going to take off the part that matches, and I have the part that's left. And now I have we're doing mixed numbers, so we're not doing decimals. So now I have part of this expression. I don't have anything else to bring down. Part of this expression that's smaller than my divisor. So this is my remainder. Now what that tells me is 237 fifths is the same as 5 goes into there 47 whole times. And then I have a remainder of 2. So I have 2 fifths left over. Now when we write 47 and 2 fifths, you know, even though it looks like these are touching, what we really mean by that is that's 47 in addition to that 2 fifths parts. So that's going to be important because when we start working with letters, we have to understand that you can't write things touching unless they are actually multiplying. So if we intend them to be adding, we need to put a plus there when there's letters involved. All right, so what we're going to do is talk about long division with polynomials. And if you understand how this works, 5, we try to match 5 to 23. We got close to 20. We took off the part that matched. We brought down the next part of the expression. We again try to match that as closely as we could. And if you understand that process, we subtracted off the part that matched, then you're going to understand what's going on here. If you don't understand long division normally, this is going to be very confusing to you, I imagine. So let's say we want to divide 2x cubed minus 4x squared plus 5x minus 7. I'm going to divide that by x squared plus 2x minus 1. Okay, so x squared plus 2x minus 1, that's my divisor, so I'm going to write that out front here. And then this 2x cubed minus 4x squared plus 5x minus 7 is by dividend, and that's what I'm dividing into, so I'm going to write it inside here. And now I'm going to try to match this front part to this expression as closely as I can. Now, there are just way too many different parts to this expression. You know, there's 3 parts to this divisor, and there's 4 parts to this dividend, and trying to match all that stuff up, it's too much. It's too much. So instead, what I'm going to narrow my focus is I'm going to try to match the most important parts, and that is the leading terms. This x squared term I'm trying to match with this 2x cubed. Those are what we call the leading terms, the highest power terms. Oh, I don't know where that came from. Okay, so I'm going to ask myself, what do I multiply x squared by to get 2x to the third? And the answer would be, I need to multiply by a 2 and an x. Now, some people might write that above the 2x cubed because they're saying that's the term I'm matching. I like to write it here because the powers, I like to line the powers of my variable up with each other. So, you know, that's a reason why I like to put it in the x column. You know, but again, you can write it in the front here if that makes you feel better. That's up to you. So now what I'm going to do is I'm going to take 2x times this whole expression. I'm working with the whole expression, but I'm only focusing on trying to match the first terms, the leading terms, the most important parts of the expression. So 2x cubed plus 4x squared minus 2x. What I'm doing here is I'm just, you know, distributing this into that expression, right? So multiplying each part of that by the 2x. And then just like before, you know, I did 4 times 5 is 20. And then I took off the part that, you know, I tried to make it match as close as I could, and I had, you know, the part that didn't match. Same thing here. I'm going to take off the parts that I already have, so I'm going to change all these signs. We don't usually subtract polynomials. What we do is we add the opposite. So 2 minus 2, those cancel out. -4 and another -4 make a -8x squared, and then 5 and 2 make a 7x. And then I bring down the next part of the expression, just like I did before. And now I start the process over. I'm asking myself, what do I, again, I'm trying to match my divisor to what's under here. And again, it's too much information, but I'm going to try to match the most important parts, the leading terms, So what do I multiply x squared by to get -8x squared? You always start by trying to match it perfectly. And the answer is I need a -8. So I'm going to take -8 times my divisor. And again, I'm going to distribute that through, and that's where I'm going to get these -8x squared, -16x, +8, and then I'm going to change my signs. I'm going to add the opposite. And so I'm going to get, again, -8 and +8 cancel out. 7 and 16, both positive, make 23x. And then -7 and -8 make it -15. And now this tells me, oh, I ran out of, you know, this power of x is lower than my divisor, so this is my remainder. As soon as I hit a lower power, that's got to be lower, not the same. Notice that when I had -8x squared, this had the same power as x squared. I could keep going. But once I reach a power lower for my variable than my divisor, that part is my remainder. So let's say we have our answer here is 2x minus 8, the quotient part that divided evenly, plus my remainder over what I'm dividing by, x squared plus 2x minus 1. So let's do another one of these, kind of see if we got the idea down. So we're going to divide, and we'll say we have 8x minus 4 plus 3x cubed, and we're going to divide that by x squared minus 5. All right, so x squared minus 5, that's my divisor. My dividend, notice this is not in the right order. So I'm going to put it in the right order. I'm going to go 3x to the third. Then I'm going to leave a blank spot, and then I'm going to write 8x minus 4. Now the reason why I'm leaving that blank spot is because I don't have an x squared term to begin with here. That doesn't mean I'll never have an x squared term. I might get one, but I don't have one right now. And so I want to leave space for it in case it shows up. Maybe it never shows up. Maybe it does. We're just going to see what happens. All right, so some people like to put a 0 x squared here. I don't like to do that because I've seen too many people confuse 0x squared with x squared, which is actually 1x squared. And so at this point, I just leave it blank and not really worry about it. All right, so I'm going to go, again, trying to match this front part to this inside part. And I get too much information, so we're going to focus on just matching leading term to leading term. So what do we multiply x squared by to 3x to the third? And the answer is we need to multiply that by a 3 and another x. So I'm going to take 3x times x squared minus 5, and I'm going to distribute that. And again, like I said, you could write the 3x over the 3x cubed, the part you're trying to match, but that's not how I write it. And so I'm going to get 3x to the third and negative 15x. Oh, negative 15x is over here, not the x squared spot. So you'll notice where I wrote my number up here, my expression that I'm multiplying by, that's actually where my thing ends at. So it tells me, oh, you better write your last term underneath this 3x part. If you don't, then your things aren't set up right. As long as this is a constant, that would be true. Then I'm going to change the signs. So minus, plus, add. So I get 3 and negative 3 cancel out. 23x minus 4. And notice again, I'm at a lower power than my divisor. So I'm done. My answer is 3x plus 23x minus 4 over x squared minus 5. Let me do one more here. Let's say we wanted to do x cubed minus 10 divided by x minus 2. Okay, so x minus 2 is my divisor. X cubed, I don't have an x squared term, I don't have an x term. Minus 10, there's my constant term. So I'm going to ask myself, what do I multiply x by to get x cubed? And the answer is, I need an x squared. So x squared times x minus 2 is going to give me x cubed minus 2x squared. Then I'm going to change the signs. And so again, nothing here. I'm just going to drop this 2x squared down. And then if you want to, you can drop down the blank spot if you want. And then I'm going to start over. I'm going to ask myself, what do I multiply x by to get 2x squared? And the answer is a positive 2x. So I'm going to take 2x times my x minus 2. So 2x squared minus 4x. Change my signs. Okay. 2 and negative 2 cancel out, you get 4x. Bring down the next part of the expression, minus 10. What do you multiply x by to get 4x? The answer would be positive 4. And notice, this is telling me, hey, I'm kind of running, this should be the last thing I should do, and the rest, if there is any rest, should all be remainders. So 4 times x minus 2 should be 4x minus 8. Change the signs, and that gives me negative 2. And again, that's a constant, that's a lower power than x. So my answer to this problem is going to be x squared plus 2x plus 4 plus negative 2 over x minus 2. Now those 2's don't cancel out because 2 is not a factor, or negative 2 is not a factor of the denominator. You can write it this way, though usually how you would see this written would be in this format. X plus 2x plus 4 minus 2 over x minus 2. So they bring that down. Now, be careful about changing that from a plus to a minus. Let's say you had a different problem and you got something like 3x minus 1 plus negative x plus 4 over x squared minus 1. Let's say it looked like that. And you said, oh, I want to bring that minus in front of here. In order to do that, what you'd have to do is make this x positive, but you'd also have to make the 4 negative. And then you could write it that way. So if you just put that minus up here, but you left that 4 as a positive, then that would be wrong. So be careful about that. When it's one number, it's no big deal to change that sign in front. But if you have, multiple terms up here, be careful about changing the plus to a minus, because then you have to change all the signs on top. You can do it. There's no big deal. And then, like I said, most books would a lot of times do that. But, just be careful about it.